HVAC Thermo 11. I see that you worked this problem with rule of thumb equations, but I tried to solve it with specific heat and mass flows, but couldn't figure it out. Do you have a solution worked this way just in case? Having taken the test, I know that my mind won't trust what I think I know and was looking for an alternate solution. If you don't, that's fine as well. So this problem was about an air handler with a heating coil. And the way I set this one up was I said that the heat that's supplied by the water, Q dot water, is equal to the heat that goes into the air, because that's the goal, is to heat that air. And then I expanded on that by writing the rule of thumb for both. So for the water side, I wrote 500 GPM delta T. And of course, that's the delta T for the water, so we can use a subscript there to distinguish. And I set that equal to the sensible heat that goes into the air, which is 1.08 CFM delta T. And we can call it delta T air. And your question is whether we could do that with kind of a mass flow rate approach. How did you put it? Tried to solve it with specific heats and mass flows. So I think what you're getting at is you want to write instead like a MCP delta T, or maybe M dot because it's a mass flow. And you want to do that for the water side. And then you want to set that equal to a mass flow times the specific heat of air times the delta T for the air side. And I have no problem with that. In fact, I think we can do that and demonstrate that it leads to the same result. So I know not everybody on the call probably has the numbers handy from this problem, but let's just give it a shot anyway. So we would want to get the mass flow rate of water, since that's what we're looking for in the problem. Ultimately, we're looking for a volume flow rate, so it's going to be in GPM. But we can solve for the mass flow rate of water to start off. And we'll have the mass flow rate of air times the specific heat capacity of air times the delta T of the air divided by the specific heat capacity of water and delta T on the water side. And then if we plug that in, the volume flow rate of the air in the problem was 5,000 CFM. So let's write that as cubic feet per minute. And then that's being divided by the specific heat capacity to get a mass flow rate. So in order to, if you want to get a mass flow rate, you can do density times volume flow rate, or the same thing as volume flow rate over specific volume, because the specific volume is the inverse of the density. So I'm just going to divide by the specific volume. And I'm using a standard specific volume value of 13.5. If you want to be more precise, you can use the particular conditions of that problem to get the exact specific volume. And if I'm off by a little bit, that's probably why. And that's going to be cubic feet per pound of air. And the specific heat capacity of air is typically taken as 0.24 BTU per pound degree Fahrenheit. And then the delta T was 68 degrees minus, I think it was 15 or 18. Can't tell from my chicken scratch, but that's degrees Fahrenheit. And now for the denominator, we have the specific heat capacity of water, which is 1 BTU per pound degree Fahrenheit. And the delta T for the water side, which was 165 minus 140 degrees Fahrenheit. And now let's cancel some units. We're going to lose degrees Fahrenheit. We're going to lose BTU per pound degree Fahrenheit in the specific heat capacity. And we're going to lose cubic feet. So we end up with pounds per minute. And if you calculate all of that, you get 188.4 pounds per minute. And that's pounds of what? That's pounds of water. The density of water, or the weight of 1 gallon of water, I guess, not so much the density. There's 8.34 pounds per gallon. So that gets rid of pounds. And if we do that division, we get 22.6. And this is no longer a mass flow rate. I guess that is a density, isn't it? Because we just went from a mass flow rate to a volume flow rate. So the volume flow rate of the water is 22.6 GPM. And I think in the solution video, I come up with like 21 point something that rounds to 22, and then the answer choice is 22. So you're going to choose answer choice C regardless. So hopefully that helps. In terms of, I didn't have this solution worked this way just in case, but you can certainly do this on the fly. So if you were bothered by the rules of thumb and you wanted to do it using this method instead that you prefer, you're welcome to do that. It does come out. You mentioned that you weren't able to figure it out. So hopefully this helps straighten that out. But more concerning than the particulars of this problem to me is your statement at the end that you've taken the test and you know that your mind won't trust what you think you know. And I just want to kind of tackle that head on because, first of all, you do want to know these rule of thumb equations, right? And you want to know this. I actually like that you prefer this method because it shows me that you like to see things from the bottom up, and you're probably going to be very careful with the units and make sure everything checks out. So that's wonderful. And I think it's great, as I mentioned in the previous question, to know two ways to do something. And these rules of thumb are very valuable and handy, and they will save you time. They're not better than this. They're an alternate approach that may be faster in certain cases when it's appropriate to do so, which is basically anytime you're within a close range to the standard density. If you think you have very cold, dry air, you may want to be cautious about rules of thumb. If you have very hot, humid air, you may want to be cautious. But if you're in that sweet spot in the middle, and even if you're not, it's always a great first shot. If the answer choices are not very close, you're probably good enough with the rule of thumb. And, if in the past you have struggled to kind of trust yourself to work through these problems, you're on the path. So I don't want that limitation to stand in the way of you making progress as you study. Developing self-trust is a process. It's something that's earned. So as you do the work, as you put in time, as you solve these problems, potentially two ways, potentially your way and with the rules of thumb, you're doing a lot of work and you're adding a lot of knowledge and skills. So you're going to develop that trust as you do the work. And my hope is that when you get to the end of this thing, you'll say, I do trust myself because I noticed things before they even became issues. And, you're going to be very different when you get to your next go around on the exam than the past one. So good question. Keep going. Don't get discouraged. And, continue to insist on being able to reconcile multiple methods to get to an answer. And I think that that'll serve you incredibly well.